linear. What do you guys got? Slope-intercept form is what?
Y equals mx plus b.
Those of you guys that are gone today, they've been writing down notes and getting ready and filling in a few things, and I'm quickly catching up because technology was... What are some other equations of lines? Lines.
Point slope.
Point slope. Y minus y1 equals m times x minus x1, and that's the one that I really like for calculus. Did you get the really? Really. Okay. There's also the really boring, like ax plus by equals c. Ew, who actually likes that one? I don't know. But whatever. Standard form. Non-linear. Give me some stuff. Radical x. Log of x. But if we want to get ready for calculus, let's say ln instead, because we can make any log into terms of ln with a change of base formula. How about e to the x?
Exponential, x to the power of n.
Ooh, that just got exciting. We could do like polynomial, right? X to the power of n, where n is an integer. Remember the snazzy symbol for integers? Plus or minus 1, 2, 3, 4, 5, 6. Not rationals where you have decimals and fractions. Anything else? Those are the main ones, right? Radical, rational, polynomial, logarithmic, exponential. Sounds good. Oh, wait. Trigonometric, we'll just write one. Trigonometric, we'll just write one. Okay. Good deal. Let's keep going. You guys checked it. And it worked, right? Ignore all the extra stuff showing because it's not supposed to be showing. Yay, go team. Okay. Substitution. Easy cheesy stuff, right? Wait a minute. Hold on. We're solving systems, aren't we? If we're solving systems, then question. Why do we need to think about these two equations together, not separately?
There's no y.
There is a y. That's the whole struggle, right? How can we solve for two variables with only one equation? We can't. We can solve for y by itself and make like a graph, but we need to solve the system. Ah, gross. Why is substitution necessary? Why not elimination? Yeah, no, not elimination. Substitution, which one are we going to choose?
The bottom.
Yep. How do we solve?
So rewrite to x.
We could rewrite it. X equals
10.
y10, Sean.
Oh, because it's our log base 10.
Yeah, it's a common log, right? Log base 10. What's the other way of solving if you don't remember how to transform into exponential form? How do we undo log base 10?
You can put the big 10 on the
Big
bottom.
old 10. Big old 10, right? 10 to the power of log base 10 are inverses, so x equals 10 cubed, hence x equals... Oh my goodness, this is taking us way too long. 1,000, right? 3 zeros after the 1. What do we do with that 1,000? Sorry, people in the back. There you go. Back substitute. Plug it in, plug it in, right? We solve one equation, we go plug it in the other. So we can go ahead and say, hey, not only do we know an expression for x, we know a number for x. Sweet. 1,000 plus y is equal to 2. How do we solve? Square both sides. Then 1,000 plus y is equal to 4. Now what?
Subtract.
Exactly. So y is equal to, mental math, there's negative. Guess what the one intersection point would be if we were to graph both of these equations? Would you have to make your window something crazy to get there? Yeah. Would Zoom Fit maybe get there? Maybe. Maybe the math is easier than playing or struggling with that window. Dun 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 dun. How we doing? Systems are about to get a little bit exciting, huh? Okay. So, what else is going on? Let's find some more interesting systems. You okay?
Okay.
Let's go. What about this guy? Check graphically, but don't solve graphically. You're allowed to check by graphing and finding the intersection points, but how do we solve? Ideas.
Substitution.
Why not elimination?
Because the squares, right?
They're not alike, are they?
No.
So how are we going to cancel them? we're not. Some of you are like, multiply everybody by x. You just made life a lot worse. Don't do that. So elimination is a bad idea. Substitution is a great idea. Which one do you think I would suggest choosing to use substitution on?
Top.
I would choose the top, because isn't it going to be easier to solve for just x or just y? But the top has fractions. Everybody hates fractions. Just kidding, they're our friends. But can't we just multiply everybody by 2? Oh. So if we multiply by 2, we get negative x plus 2y equals negative 5. If you're a fraction phobe, if you have a fraction phobia, I'm sure there's a nice technical term for it, but what else? Just multiply everybody by 2 and say, hey, sweet, let's solve for x. And can you guys see that solving for x, I would add x, then add 5. X equals 2y plus 5? Now what do I do with that guy? Back substitute. To the same equation. No, you'll just get 0 equals 0. Who am I plugging it into or in for? Other equations, x, right? Alright, let's go plug it in. So I have 2y plus 5 quantity squared plus y squared equals 25. How are we doing? Are we going to kill puppies?
We're not killing.
Not today. It's a minimum day Friday. Ruin it. So, 4y squared plus, what's my middle term? Because we know there is one, because we're smart honors pre-calc kids.
20y.
Good. 10y plus 10y is 20y. You got a FOIL, outer and inner double. Equals 25. Let's combine some like terms. Let's get everybody to one side, because we know if there's a quadratic, we need to get one side equal to 0, right? 4y squared plus 1y squared is 5y squared. Plus 20y equals 0. True? Sweet, let's pull out that 5, let's pull out that y, and we end up with y plus 4 equals 0. Whenever we have factors equal to 0, what do we do? Set them both equal to 0. Why is that good according to our graph to have 2 values for y? We have 2 intersections, and one looks to be at y equals 0, and one, sure, why not? 1, 2, 3, and let's just put another tick mark 4. Oh wait, remember, there's that equation just waiting to be plugged into, right? So let's take those y's, let's go plug them into that x equals equation, and we end up with x is equal to, plugging in 0, 2 times 0 plus 5. Uh-oh. You guys following? Plug it in, right? 2 times 0 plus 5 is 5. Negative 4 times 2, negative 8 plus 5 is negative 3. Keep the order the same and we'll be good. So we have our 2 intersection points of 5, 0, and negative 4, negative 8. How would we solve this by graphing?
Negative 4.
Oh, did I write it backwards? Both hands. I wrote both of them backwards too. No, I didn't. I wrote the other one.
Yeah.
Used to x coming first. Negative 3, negative 4. Okay, question. How would we solve using our graphing calculators if we needed to? Y is not by itself. Get it by itself. Okay. So this y would end up being y equals 1/2 x minus 5/2. Can I plug that into y1? Okay. But don't I also need y2? Uh-oh. Is this one a little more complicated? So I have to do y equals 25 minus x squared square rooted. Except that's not totally right. That'll only give you half of the circle. How do I get the other half of the circle? Because I can't do it together since it's not a function. I have to have them separate.
If we're adding a square root ourselves.
We need to include plus or minus. So wait a minute, plus or minus, is that just going to be y2? Or is that really y2 and y3? See what I mean? So you have to do one positive square root as one graph, one negative square root as another graph. Then you're going to have to find intersections using, I don't know, some combination of the two. I think the math might be easier. Call problem number this one. can. What do you guys want to do?
I was thinking we could multiply the two equations that agree. This is so too.
We want to make a match somehow. I see one quick multiplication if we were to cheat and use elimination. Some of you are like, nah, substitution, that's easy, solve for y. Totally fine. But if you did want to use elimination, what could you multiply the bottom one by? I see this as being the easiest route. Oh, you guys just don't like the fractions? All right, fine. Let's get rid of the fractions. Multiply him by 4, multiply him by 4.
Yeah.
All right. Then he becomes 2x plus 3y equals 10. He becomes 3x minus 4y equals 16. Aw, stink. I would just multiply the bottom by 3/4.
Would it be equals 40 on top? It's 4 times 10.
Process. It's too focused about my other one. I see these guys with opposite signs. Let's make them match, yeah? Let's multiply him by 4. Let's multiply him by 3. Then we end up with, check my math, 8x plus 12y equals 160. 9x minus 12y equals 48. 17x, booyah, eliminated, 208. X equals 14. If it goes in evenly, has anybody figured that out? What's 208 divided by 17? Ew, nothing nice. Let's do math fraction, see if it reduces. We're just cheating with our calculator. Nope, it doesn't reduce. All right, never mind. 208 over 17. You guys double check my math though, right? That was right? Sadly. So what's y going to equal? Aww. We didn't use substitution. There's no equation necessarily waiting for us. So what do we plug it into? Whatever one we want. Him or him or him or him. What do you guys want? Bottom left? Okay. So bottom left would be 3/4 times 208 over 17 minus y equals 4. Ew. 208 divided by 4? Yeah, it does. 52 times. 3 and 17 doesn't work. That'd be 156 all over 17 minus y equals, you get common denominators, this would be 68 17ths. Changing 4 by multiplying by 17 over 17. Add the y, subtract the 68, y ends up equaling 88 over 17. It's not pretty, but it works. Ugh. We're solving, huh? What else is there to this section? Solve graphically? What does that mean? Plug into your calculator. Wait, did we already talk about how you plug into your calculator?
Yeah.
Don't you have to get y by itself?
Yeah.
And if there's a square root, don't you have to get y by itself with a plus or minus? How many equations are you going to have to graph? You're going to have to graph y1 for here, and y2 and y3 for making one a positive and one a negative to get both those equations in. How are you going to use a grapher for this guy down below? Oh, that could just be y1. This guy, couldn't we solve for and make him y2? When you're solving with your graphing calculator, what are you finding? Yep, you're finding the intersections using, you guys remember?
Calc value?
Second trace, which goes to the calc menu, right? Second button, trace button. Use the intersection. You have to say first curve, second curve, go. So, solving graphically, not too bad, using your graphing calculator, right? Oh, we're so close. What's the last thing that might show up? Oh. Applications. If you invest money and you sell stuff and you have costs, how are you going to break even? even. You invest money, that's like money out of your pocket, right? So you're down 16,000. You sell a product, you get $55.95, but you have to spend $9.45 for each product. How can we break even? Profit needs to equal what? Come on, business people. What you make needs to equal what you spend if you're breaking even. Basically, you want to negate that and make more money and then keep on making money, right? So, cost, what have you spent or what are you spending? What else are you spending? $9.45 for each product, right? $9.45 for each. Can we put an X? And we're making $55.95, so we're just trying to see how long will it take, how many do you have to sell in order to break even, and then everything above that, you'll start making a profit of $55.95 minus $9.45 each product. How about the bottom one? That's an easy solving one. Find the dimensions of the rectangle meeting the specified conditions. Ugh, what's perimeter? Oh, come on.
That's 2.
Add all the sides. Add all the sides. Perimeter is 42. And the width is 3/4 the length. Oh my goodness, you guys, look at these equations. Algebra 1 stuff, yeah? So why am I saying 7-1 due on Monday? Because you got this. Let's have test corrections due on Tuesday. Sound good? Test corrections due on Tuesday, but if I were you, be wise and get them done over the weekend. And otherwise, 7-1 due on Monday, and you guys are good to go when the bell rings. Happy Friday.